So we're starting section 3.3, and we're going to start by talking about power functions. Now, a power function comes in this form. The function is equal to k times x to the p power. K and p are real numbers. They don't have to necessarily be integers. They just have to be real numbers. X is the variable here. The other thing to note is that it only has one term, okay? So you have a number in front. K is called the coefficient. I'll try to spell it right. And then P would be the power or the exponent. Okay. So we're going to look at the toolkit functions and see which ones are power functions and which ones aren't. So we're going to have to remember the toolkit functions. So first we have the constant function. And so if you remember, that says f of x equals, and then some number. Your book uses the number 1, but it could be a 7 or a -2 or something. But the point is there's just a number there, okay? So you say, well, where's x? Well, there's no variable, right? Could you write that as 1 times x to the 0 power? Yeah, you could, okay? So that would be the same thing. X to the 0 equals 1. So you might remember that, but x to the 0 equals 1 by definition. And so you can write that with a coefficient and a variable with a power, and both the coefficient and the power are real numbers. So it's in that form, you know, over here, it's in that form k x to the p. Okay, so that's kind of what we're looking for here. Next we had the identity function, and that said f of x equals x. So the coefficient there is 1, and the exponent is 1. You could put those in. You could say this is equal to 1x to the first power, and that's going to be the same thing. Again, the coefficient and the power are both real numbers. Okay. So what's our next identity, or our next function in the toolkit? I think we usually do the quadratic one next. Quadratic. And so that says f of x equals x squared. Coefficient is 1, and power is 2, right? So you can put it in that form, k times x to the p. K and p are both real numbers. So far, these are all power functions. Okay, so we did the quadratic, the cubic function. All right. The cubic function says f of x equals x to the third power. Again, you could put a 1 in front of it, but you know, you have a coefficient that's real, a power that's real. It's all good. Power function. Let's see, what's next? The reciprocal function. The reciprocal function says f of x equals 1 over x. Now, that one you might say, oh, that one looks different. But I can write that as 1 times x to the -1. So you might remember the definition when you have, you know, n to the, now I think they usually use b. I was trying to think of what letter they use. If you have b to the -1 power, that's 1 over b. Remember that? Okay, so you can go the other way. So I have 1 over x. I can write that as x to the -1. Again, I have a coefficient 1 and a power of -1. Those are both real numbers, so it's a power function. Alrighty, what one do we want next? Oops. Okay, the reciprocal squared function. Squared. Okay, so f of x equals 1 over x squared. But similar to the reciprocal function, I can write that as 1 times x to the -2. Again, I have a coefficient of 1, an exponent of -2. Those are both real numbers. It's a power function. All right, the square root function. There are 8 of these. So f of x equals the square root of x. And in the past, we've seen that. We've worked with it. We've graphed it. We've made transformations on the graph. But I want to write it as a power function. See if I can. Well, you might remember that that is x to the 1/2 power. So the rule says if you've got the nth root, of x, or whatever you've got in there, b, it's x to the 1 over n. Okay? So that's how that works. Now, I have a coefficient of 1. I have an exponent of 1/2. Those are real numbers. Therefore, it is a power function. And then the last one is the cube root function. So f of x equals the cubed root of x, which we can rewrite that as x to the 1/3 power. So again, we have a coefficient of 1. We have an exponent of 1/3. Those are both real numbers. Therefore, it is a power function. Turns out that all of these functions, our toolkit functions, were actually power functions. They could all be written as power functions. All right, well, that was exciting.